You know that little blue dot on your map? The one that tells you exactly where you are right now? It feels so simple, doesn't it? Almost instant. But behind that one little dot, there is an incredible dance of technologies that have totally changed how we see our world. Today, we're going to pull back the curtain on those unseen systems that guide you every single day.
So let's just start with the biggest question right off the bat. How does your phone really know where you are? I mean, really think about it. It's not magic. What's actually happening is a constant high-speed conversation between your phone and a network of satellites thousands of kilometers up in space. So let's break down how that conversation works.
All right, the first big piece of this amazing puzzle is the system that actually pinpoints your location. And it's not just one thing, it's this whole global constellation of satellites all working together. You can think of them like a giant clockwork in the sky, constantly beaming signals down to us here on Earth.
And that system has a name, GNSS, which stands for Global Navigation Satellite System. And honestly, it's pretty much what it sounds like, a whole system of satellites that help us navigate anywhere on the globe. Your phone, your car's navigation, even those high-tech devices surveyors use, they're all just different kinds of GNSS receivers. So, how in the world does this work? Well, imagine your phone is always listening. Up in space, dozens of satellites are constantly shouting out a signal that basically says the time is now, and that signal is stamped with the exact time it was sent. Your phone catches these signals and notes the time they arrive. And because we know the speed of light, that teeny tiny delay between when the signal was sent and when your phone got it tells you exactly how far away you are from that satellite. Do that with at least 3 satellites and your phone can pinpoint its location on the globe. It's a process with a fancy name, trilateration.
And here's something cool. This isn't just one country's project. A lot of us just say GPS, but that's technically just the American system. GNSS is this huge global collaboration. You've got Russia's GLONASS, the European Union's Galileo, and China's Baidu system all working in parallel. And for us, the user, that's awesome. It means more satellites, stronger signals, and a much more reliable location. In fact, your phone is probably listening to several of these systems at the exact same time.
And this tech is for way more than just finding the closest pizza place. I mean, these high-accuracy receivers, like the one you see here, they're used by surveyors to map out locations with millimeter precision. That level of accuracy is the absolute foundation for everything from building bridges to scientific studies about the Earth itself.
Okay, so GNSS gives us our little blue dot. It tells us where we are. But what about the map behind the dot? For that, we need to look at what else these satellites are doing besides just keeping time.
Right. The satellites that build the maps we use aren't just taking pictures. It's not like a camera on an airplane. No, they are packed with sensors that can see the world in ways that are totally invisible to you and me. You could almost call it a kind of superhuman vision.
There's a name for this science. It's called remote sensing. And it's really the art of learning about something without ever physically touching it. By analyzing the light and energy that reflects off the Earth's surface, these sensors can tell us an absolutely staggering amount about what's going on down on the ground.
Think about this for a second. Our eyes can only see a tiny, tiny little slice of the electromagnetic spectrum, the part we call visible light, red, green, and blue. But a satellite sensor, like the ones on the famous Landsat satellites, it sees so much more. It sees in different bands of infrared light. And this is the key, because different things on Earth, like water, soil, and healthy plants, all reflect these invisible types of light in their own unique way.
And here's where it gets really powerful. This quote might sound a bit technical, but what it's saying is incredible. By measuring how much of a certain kind of infrared light a forest is reflecting, a scientist can literally tell how much water is in the leaves of the trees. They can spot a forest that's stressed by drought from an orbit 700 kilometers away. It's like giving the entire planet a health checkup from space.
So, we have our precise location from GNSS, and we have these incredibly rich, detailed images from remote sensing that see more than we can. But how do you put those two things together to make something you can actually use? Well, that's where the third and final piece of our tech puzzle comes in. This is the digital brain of the whole operation.
And that brain is called the Geographic Information System, or GIS. It's the software that takes all this geographic data, the satellite images, the location points, maps of roads, rivers, you name it, and lets us see connections and patterns and trends that would be totally invisible otherwise. It's what turns all that raw data into actual, actionable intelligence.
Probably the easiest way to wrap your head around GIS is to picture a stack of transparent sheets, like old-school overhead projector slides. The bottom layer might be the satellite image. On top of that, you lay down a transparency that just has the roads. The next one has rivers. The next one has property lines. When you stack them all up, you can start asking really smart questions.
Now, GIS basically handles all this info in two main ways. First, there's raster data. That's just a grid of pixels, right? Perfect for things that are continuous, like a satellite photo or an elevation map. Then you have vector data. This uses points, lines, and shapes to represent specific things with clear boundaries, like a point for a single tree, a line for a road, or a polygon for a park's boundary. A truly powerful GIS uses both of these together to build a complete model of the world.
Okay, now for the really cool part. When you combine all three of these technologies, the GNSS, the remote sensing, and the GIS, you create this incredibly powerful workflow that lets us go from just collecting data to making really complex, really smart decisions about our world.
The way they all work together is what's so critical. So a surveyor might go out and use a super accurate version of GPS to lock in a few exact points on the ground. Then a satellite flies over and captures one of those amazing multispectral images. Finally, all of that gets loaded into the GIS, which uses those hyper-accurate ground points to make sure the satellite image lines up perfectly with all the other map layers, like roads and property lines. And once everything is layered together, well, now we can answer some huge questions. We can ask, where are the crops healthiest? Which hillsides are at the highest risk for landslides? How is our city actually growing? What's the fastest possible route for an ambulance? This technology is absolutely central to modern farming, disaster response, city planning, you name it.
So just remember that number, 3. It's not one single technology doing all the work. It's the powerful combination of these three things. GNSS for knowing exactly where we are, remote sensing for seeing the big picture, and GIS for understanding what it all means that has completely revolutionized how we see and manage our planet.
So where does all this go from here? Well, putting these technologies together isn't just about making better maps anymore. It's about creating a living, breathing digital version of our entire world.
We've literally gone from that one little blue dot on a phone screen to building what experts are now calling a digital twin of the Earth. A model that's constantly being fed new information, letting us watch our world change in almost real time and even predict what might happen next.
And that kind of leaves us with one last big thought. As our ability to map and analyze our world gets better and better down to the tiniest detail, the real question isn't just what problems we can solve, it's what new questions will we even think to ask? What incredible discoveries are just waiting for us to find them? The potential is just absolutely limitless. Thanks for tuning in.